Now, when we are doing the centrifugal pump engineering, now for can you see the screen? Now I have considered the three different cases: design case 1, and design case 4, and design case 5. Now here the column number 2 and 3 I have purposely kept it blank because this column will be filled in the later slides. Now here the three different combinations are given. If you see in the first parameter, it is the rated flow. The second parameter is rated head, specific gravity of the liquid, what is the type of liquid, and what is the operating temperature, so normal and the maximum. So these are the basic parameters which will be given by the end user or client to you as a rotary equipment engineer. Now your responsibility is to select the right solution for these different design conditions. So now if you wish, you can note down the design case 1, 4 and 5. So rated flow, rated head, these are the two important parameters for the centrifugal pump selection. Of course, the temperature and the specific gravity are there, but these are utilized for the auxiliary selection also. But for this, first thing important is the rated flow and the rated head. Now here, there is a skid 1 available. So this is the centrifugal pump. I will discuss what is the type of pump in detail later. But just for your information, this is the centrifugal pump. This is the electrical motor. This is the coupling which is connecting the motor and centrifugal pump. And all this, it is mounted on this base plate. Now this is the suction nozzle, and this is the discharge, and this is the drain connection. Now this is the one type of configuration which will be used for which design case. So if you know the answer, just keep your answer ready and then we'll discuss later. So this is the skid 1. So you have to just keep your answer ready for which design case out of 1, 4 and 5 which I showed in the previous slide, for which design case this pump can be utilized. This is the second skid. Again here it is a motor, this is the pump, and this is the coupling and coupling guard. So now for which design case 1, 4 or 5 this skid 2 can be used. So this is the question to you all. So you can keep your answer ready and then we'll discuss later during our QA session. We have seen in the first slide the design case 1, design case 4 and design case 5. Okay. Now the same figures are reflected here. Now if you see in the first slide, I had shown the parameters only up to the first 5 rows. The rated flow was shown, rated head, specific gravity, liquid, and the temperature. Now, so here, if you see, first you take the design case 1. Here the rated flow is 314 meter cube per hour and head is 86 meter. Kerosene liquid with specific gravity of 0.67 and operating temperature is 172 to 195. So for this given condition, we have selected the OH2 pump. Now here we are comparing the different type of configuration. Now if you see here, for this head of 86 meter, we are using the number of stage single. So OH2 type pump is a single stage pump. Suction nozzle is 8 inch, discharge nozzle is 6 inch, impeller dia is 266, and speed is it is a 2970. I will just take it down here. Okay. Now if you take the second design case, which is a 2. Now here the flow is drastically reduced here. It is almost 25% of this value, whereas the head is almost double. But still, the pump type is a OH2, which is a single stage. It means the OH2 pump has a combination of the flow and head. It can have the same configuration OH2. But what is having effect here on the suction and nozzle discharge side? Here it is a suction is 8 inch, and for this case it is a 4 inch. It is almost half. Why it is happening? Because here the flow is drastically reduced as compared to this. So the nozzle sizes are decided based on the flow condition. Since the flow is reduced, the suction nozzle as well as the discharge nozzle size is also reduced. But if you see here, the impeller diameter is more. Why impeller diameter is more here? Because the here head is doubled. So combination of the flow rate and the rated head, it will decide what should be the diameter of impeller. Single parameter will not decide the diameter of impeller. Nozzle size, definitely it will be governed by the rated flow. Now you take the design case 3 here. If you compare it with respect to the one, flow rate is almost 70%. Okay, if you multiply it this thing, so 70 to 75%, it is coming 233. Now what is the head? The head is almost 3 times. Here it is a 86 meter and here it is a 290 meter. Now you see the configuration has changed now from OH2 to BB2. What does it mean? The number of stages are 2 here. So what does it indicate? Overhung pump OH2 cannot meet the requirement of 233 with 290 meter head generation. 233 it can handle, but along with the rated head of 290 meter, OH2 pump is not sufficient. So we have to go the another configuration, which is a BB2. So BB2, it is a between bearing pump, two-stage pump, which is a radial split. Now next case is, now here also you see, since the flow is slightly, it is 70% of this, the nozzle size, what is the effect here? Instead of 8 inch, here it is a one size, it is 6 inch. Similarly, the discharge nozzle, instead of 6 inch, here it is a 4 inch. So nozzle size is being governed by the flow rate. Okay. Now next is the design case 4. Now if you see here with respect to the case 1, the effect, the design condition is what? The flow rate is almost 10 times of this flow. It is a 314, here it is a 3300. And head is 50 meter, which is roughly, you can say, the 60%. So what is the major impact? Here the flow is increased significantly. So neither this OH2 nor BB2 pump can and handle this large flow. Here it is a BB1 pump. So design case, if you see here, since the flow rate is significantly high, neither OH2 nor BB2 is sufficient. So we have another configuration available to use, which is a BB1 pump. Now, if you see here, what is the effect on the nozzle size with respect to the design case 1? For 314, it was 8 inch. Now, for the 3300 meter cube per hour, the nozzle size has significantly increased, which is almost 3 times of this size. Here also, discharge nozzle, instead of 6, it is at a 16 inch. And can you see the effect on the impeller operating speed of the machine? The larger flow of the machine, it is operating relatively at a lower flow, lower RPM. Here, all these three pumps where the flow rate is moderate and the head is also not very high, all pumps are operating at 2970, which is a two-pole motor. But here, as the flow has significantly increased, the operating speed has come down. Even the impeller diameter has increased significantly. So the different combination of the flow and head, it is giving the different configuration selection. Now you take the case 5 where the flow rate is more or less, it is a 60% of this, but here head is 630. Now with respect to 86, if you see, it is almost 6 times. So can we use the same pump? No. Here it is a BB3 or BB5. These both are the multi-stage. BB3 is the axial split casing pump and BB5 is the radial split with the double casing. Now see the number of stages. It is the increase from 1 to 5. So 5-stage pump it is used for because it is a high head generation is required here. Similarly, for this design case for you had seen, this is also the single impeller because the head generation is low. So different combinations of the flow and head are giving the different configuration selection. And after that, once the configuration is rightly selected, then you decide what should be the suction size, discharge nozzle size, what could be the operating speed. Now here again, if you see the because of the high head generation, pump has again, it is RPM is in case of 1000 to 2900 RPM. So depending on the combination of the flow and head, different configurations will be selected and based on the flow rate, nozzle sizing will be governed, and combination of head and flow, it will decide what should be the impeller dia and what should be the operating speed. So you see, now you can imagine what is your role as a rotary equipment engineer, because client is dependent on you, that you guys are doing the engineering, and client trust you that you are giving the right solution to the end user. So this simple example of the different combinations of the flow and head, it will make you realize that you guys have to be thorough in your subject, because client is dependent on you to seek the right solution. Because this pump, once it is designed and operating on the site, it has to operate for the 20 or 25 years. So it should be a trouble-free operation. It should be reliable and it should be the right solution.